In this first video, I want to set the groundwork by asking a very simple question. What's a computer? What are they? Why do we have them? Why do we use them? This is a question that for a lot of my students who have been born in the computer science era and never knew anything before a PC, computers are just a part of their life. And it can be hard to imagine life without computers, without our cell phones that we have attached to us. And so it's important to really understand what is a computer? What does it do? And so to answer that question, I'm going to go to a very fundamental definition, if you will, and we're going to use a little bit of a diagram here to explain what a computer is. So let's start out with input. Usually we have some level of information or a problem or something that we want to feed to a computer and have it solved. In the basic understanding that most people have early on is I want it to do a math problem for me, or I want to have it help me write a paper. But in reality, they do a lot more. We build videos, we build social media, we do a lot of different things on computers, and there's a lot of things we use every day, like my watch, that actually qualifies as being a computer. So a computer, by definition, takes input of some sort, and then there's some sort of processing or computing or computation or algorithm that is run. And in order to do that, the computer needs to have storage to maintain temporary variables, areas of memory where I can store my term paper or my video or whatever it is, or the web page on the servers. We need storage. And storage and the processor move back and forth with information to store and use the information as needed to come up with a solution, which then becomes the output or the final product of what I've created. So this is collectively known as the data processing cycle. And the data processing cycle is really what defines a computer. Now you can make an argument, for example, that a sundial is a computer because it takes input from the sun. It's on a scale so that it's got a set of markings that tell me what time of day it is, and it's positioned such that the shadow of whatever the arm on the sundial is gives me the correct time of day, and the output is what time of the day is it. You can't make that argument as well for a garden rake. Okay, and you can think, well, I input by pulling it across my yard, but it's really not calculating anything. It's not providing any transformation of the input to an output state. Okay, so when you think about what is a computer or what qualifies as a computer, an example is a video camera that I'm using to create these videos. In many ways, that qualifies as a computer because it's taking the image and the sound that I'm presenting and it is converting it to a digital format and storing it in electronic file format. It then moves that information to a file on a thumb drive, or actually it's on a little flash drive that I then put in my computer and I have as a file. So even my video camera that I'm using to make these movies is a computer. And our televisions, this monitor right here, can act as a computer because of the way it can process things. Okay, it's got firmware chips in it that process signals and allow it to connect to the internet. So if you've got a smart TV of any kind, it's a computer. So there's a lot of things in our lives that are computers that we just don't think about. Okay, so one of the ways we can determine if we think something's a computer is just ask ourselves this question. Is it taking any form of input? Is it processing it and using any kind of storage to create an output that is useful for me? If it is, you could pretty much consider it a computer electronically. Okay? So, what's coming up next? In our very next video, we're going to take 1/2 of a step back and review binary math, because that's very important as we move forward. So I will see you on the other side.